Hello everyone, and welcome to Physics 1112. This is the second semester physics for algebra-based physics, and you should feel good that you've gotten through first semester, and that's quite an accomplishment. And we'll be going on to learn about more modern physics, things that happened in the 1800s and 1900s, early 1900s, 20th century. And normally I don't start out the class like this, but I I guess we just have to do it. So at any rate, this is D2L that you're seeing right here, and in D2L you have a lot of options, and I've selected our course, of course. You'll have other courses that you can select too if you're taking more than one. And we are looking at the course home right there. And there's all kinds of things. This is where things will get posted. I've got a welcome note. I've got the note about today being canceled. And actually there was an issue with D2L not being properly assigned to each of the students. So I hope that you don't have an issue with that. And if you do, it's going to be hard for you to see this in the first place. But hopefully you will email me if you have issues with D2L, and I can email the e-learning group. Okay. Or you can email them yourself. Maybe you're already that resourceful. Okay. So we've got a few things to cover. We're going to get attendance first thing and probably cover a few more things on Monday. So we'll talk about the classroom and introduce ourselves and do all that kind of thing on Monday. It's better to have me introduce myself then, but I'm not going to wait. I'm going to do that now. So, me. My name's John Adams. You can see that there. I have been studying physics for about 30 years, and even when I was working in the industry, it's always been, in the back of my mind, always a hobby and always something that I would continue to do. I've done work in experimental physics for the most of my career. I've done nuclear physics, where we look at low energy or medium energy collisions in particle accelerators, Brookhaven for one, and back east in Boston. And then there's a little bit more high energy stuff I went into, and that high energy physics allows us to probe deeper into the atom and get to find things like muons and kaons and bosons of multiple types and exotic particles and whatnot. And that was very interesting. A lot of the times I was just running computer simulations or making sure that what we were looking for was what we were going to get out of our experiment. And Fermilab is a place, Batavia, Illinois. I worked there for a while, and then I did some work in Italy with a similar, smaller, but similar group south of Rome in Frascati, and we did some work there that was great. And then, of course, I left the field, and then they discovered the Higgs boson. So at CERN, I probably wouldn't have been involved with CERN anyway, because the United States had such a small presence, and we don't need to talk about politics. So I missed out on that, but I did go back into physics after doing some other types of work, and then studied condensed matter, solid state stuff, where I looked at crystal behaviors, and the crystalline structure of iron was a paper that I wrote that I'm pretty proud of, and that ends up being the ultimate thing that we've got right now on iron. So everything that's made out of steel, all the people that work with steel and iron, they refer to that paper to get things done. So that's I'm pretty proud of that. Okay, so what have I been doing lately? I am working theoretically now, and I'm trying to show how the nature of physics, its wave behavior, is crucial to approaching what we call a grand unified theory of physics, and that is where we incorporate all four forces, gravity included, into the other electromagnetic force, the strong and the weak nuclear forces, getting all of that put together and so that they're all basically one thing. And I think I have a way of doing that. So, maybe I'm right, maybe I'm wrong. We don't know. But our class will be doing electromagnetics and looking at electromagnetic waves. So we're going to take what we learned so far, and we're going to expand on that. And we're going to learn a little bit about waves, wave behaviors, fields. We're going to note how the gravitational field was something that is very akin to the electromagnetic field. And we're going to basically take wave-like properties and start associating other types of our daily world into it. So at any rate, that's me. That's what we're going to be doing, and I'll be talking about that a little bit more. But for now, I think we need to start talking a little bit about D2L. If you notice up on the top row tab, there's a content tab. If you're not familiar with that, if you hit content, it'll take you into what we've got. So far, I don't have anything loaded as far as labs go. That'll happen soon, either today or tomorrow or this weekend. And because we're going to be doing laboratory stuff, I have to say that this class wasn't sprung on me. I've known about it for a long time, and I've been reading about the material and prepping for lectures and that kind of stuff. However, the structure of the course has recently been changed, and it doesn't get taught very often. So I don't have a lot of resources to work with. So I'm doing a lot of the heavy lifting for this class this semester. And so because of that, I'm hopefully going to be prepared every day, and it'll be a little bit more work for me than normal, but hopefully you won't notice, and we will get some good learning in. So the first thing that we have here, right at the top here, is this WeBWorK, and this is how you would go. You click on WeBWorK, and then it takes you into your homeworks, and this shows what I get to see. So I get to see over here all the instructor tools that you don't get, but you can just select homework number 1, and then you can start doing your problems, and hopefully you notice here that it closes at 11:59 Mountain Standard on Sunday night, and you should be able to get that done. This first WeBWorK isn't. It's not going to be too technical. It's mostly designed to teach you how to use WeBWorK, and it's something that we should have done in the first semester. And so there's not a lot of physics necessarily in there. It's just helping you navigate WeBWorK and introduce things. I didn't put a little blurb in WeBWorK on. Okay, so I'm going to put in there how to enter in units. It's just a little blurb. You need to put a quote, double quotes in WeBWorK to enter your number first, like 33.3 right there. See that 33.33? If you enter that in and then you put a one of the quotes, an open quote, then you can put your units. So that's important to know, and I'll note that here on WeBWorK. I'm sorry, I don't have that done yet. Okay, so class organization. Let's go there. So we have our schedule. I'm going to guarantee that this schedule is not going to, it's going to change. Okay, we're definitely going to do simple harmonic motion and waves. However, I think, and the energy and oscillations, I think we're going to be able to cram most of that into 2 days. And we're going to bump up sound. So we're going to condense the initial SHM, simple harmonic motion. We're going to condense SHM and wave, sound, Doppler, all that kind of stuff. We're going to condense that and get bump electric fields, because that is a majority of the emphasis that we want to put on this course, electricity. So we're going to be looking at electric fields, conductors, and all the things that are related to that. Then we're going to have a nice spring break, go to Cabo San Lucas. And so then down here at the bottom, after we get through with some of these things, we'll have some time left over, because we're going to crunch the beginning of the semester up, shorten it, and that'll give us some time to do some optics at the end of the semester. So hopefully the test dates will stay the same. I don't have, for the tests, I don't have what they're going to cover, because we aren't 100% sure what those things are going to be covering. And the labs will be specific to what we're learning at the time. So hopefully that works well for you. So today is Wednesday, January 28th. We're going to be doing our brief review of physics 1111, the first semester. And down here on May 8th, we're going to be doing our final exam, which is definitely comprehensive. And so you'll have to remember the things throughout the semester. One good thing that I like to do that students appreciate, I think, is the ability to do it. For each test, you get to do one side of an 8.5 by 11 inch piece of paper. You can make your put anything you want on it. You can put formulas, equations, concepts, ideas. You can solve a problem there, and just a whole bunch of whatever you feel like you can fit on that page that will help you for the test. And that does a couple of things. That helps you learn about, it kind of reinforces the ideas in your brain as you're doing it and preparing for the test. And then when you're on the test, then you have more confidence, and you can refer to your piece of paper. Gives you some memory, extra additional memory. Okay, I don't know what else to talk about there. Let's see. On the right side, you can see the homeworks due Sundays at midnight, 11:59. Don't wait, because whatever you have done at 11:59, that's when it closes. So get that in, and then we can see where the labs are due. And some labs you'll be working together, some labs you'll be working alone, some labs you'll be collaborating, some, just all kinds of, you might only turn in one lab for the group at a time sometimes. So it kind of depends, and we'll see how that goes throughout the semester. And I think that works well. I know labs make things a little bit stressful, but last semester's labs were more difficult. I believe, from what I can tell, these won't be as demanding as last semester. I guess the material dictates that, and your ability to handle it. But all in all, labs will be good. We're going to talk about statistics and how to handle accuracy and precision, and what do those mean, and percent accuracy and percent precision in your measurements. We're going to talk about that stuff. We're going to have to do that. I don't want to do that in today's lecture at all. So okay. So that's it for the schedule. Let's go back here to class organization. We'll look at the syllabus. All right, so just in case you didn't know, you're in Physics 1112, and we've got our semester, spring semester, you're in section 181. Of course, I'm John Adams, and then we're meeting at the Castle Rock Sturm campus in room 228. Our time for meetings are 11 to 2, essentially, 10 to 2. And that's my email. And so you can email me anytime. I will get this email. If you try and send stuff to me on D2L, I won't necessarily see it. And it's important that you use your student.cccs.edu email. And I've been told that I'm only to email you through that email, and work with that. It's actually so that Big Brother, the school itself, and the Colorado Community College system can keep tabs on our communications, and rightly so. So I agree with that. Anyway, that's why I've been limited to those things. And that reminds me, WeBWorK, there's a button that you can click to email me in WeBWorK as well. I don't think it's going to work. It doesn't work in the past, so I don't see why it would work now. And so all in all, just get in your email, your student email, and type in my name there at arapahoe.edu and send me an email. And that's how you get me. Okay, so we're going to be doing the physics of electricity and magnetism, and that means you're going to have to be able to mathematically handle it and learn the concepts. We have DC circuits that we're going to be looking at. AC circuits, if we have time. I don't know if we're going to have time to do that. It's saying here AC circuits are a part of it. I'm not 100% sure. anyway, I'll be definitely making sure that this is a guaranteed transfer course. So whatever it takes to make sure this GTSC1 category is fulfilled, we are going to do it. And that way you can move on and transfer to any place you would like. The OpenStax is a great resource for your textbook. It's free, and you'll want a scientific calculator, of course. I'm going to go back to the course home. If we look here in the welcome, I have your textbook right here. So you can click that link and go straight into looking at your textbook. So let's go back to the syllabus. And we're going to be doing homework, mostly through WeBWorK. And I understand the student side of it. It's not as friendly, or it's not, I don't know. WeBWorK is a little difficult to work with. However, it does work well, and when it does work. If you do have problems with a problem or anything in WeBWorK, email me and I can fix it. So as soon as you start doing your homework for the week and you run into an issue with a problem, sometimes they don't work right or they're not configured correctly, I can get in there and make it right or delete the problem from the set. I don't know how much homework will be assigned through D2L, and then either a hard copy or a digitized copy is turned in, and I'll make sure that you know when it's due, when it's assigned. Quizzes, of course, I do quizzes surprisingly through the semester. You don't know it's going to happen, so I wouldn't be late to class very often because the quiz is going to be at the beginning of the class. So show up, be there, and be ready to take your quiz. One of the things is I don't have a specific quiz grading section. So quizzes will be considered homework and a part of your homework score. So here we have the grading. We have the 15% labs, 20% hours, the hour exams. There's going to be 4 of them, 10% each. And then the final exam is 15%. We've got other here of 10%, and I might be spreading that between. I might make homework. I don't know if I like this or not. Homework will probably be 20% and labs 25%. So. But hopefully the labs are going to be easier this semester than last semester, and that'll be great. Of course, your final grades are calculated, as you can see here. The A is 90 to 100, B 80 to 89, and so forth. So shoot for what you can. We've got our census date. Last date to drop with refund is the 1st of February. So if you're not happy with the way I'm doing things, or you just feel like this isn't the class for you, I would get out before February 1st. Withdraw date, if you think you're not going to make it through, or there's issues or what have you, if you withdraw by April 13th, you'll only get an incomplete and you won't get a failure or whatever could happen that you're trying to avoid. So there's that. Finally, we have and I say finally, it's in the middle of this thing, but right after the academic integrity statement, I pretty much start skipping things. So highlighted here that, we don't want to see plagiarism, cheating, fabrication, any of that stuff. Looking over your shoulder at your friend's test, that kind of thing's frowned upon, and I don't appreciate it. And just be honest with yourself and be honest with your fellow students and the class, and you get what you get. But you can do a lot to make sure that you get what you need. And I will be giving you all the information you need to get an A in this class. So how you handle that is up to you. Okay, so our learning outcomes, a lot of these are conceptual learning outcomes. Of course, the GT pathways, this is a GT guaranteed transfer course, so we're going to make sure that that happens. And here, down here, we have the learning topics. So these are the topics that we'll be covering. And it's always nice to go down here and look and make sure that you're good on each of these topics. Even though it says recommended, we're still going to be doing simple harmonic motion. We definitely need to look at waves because waves are part of the electromagnetic studies. And I'm not 100% sure where we're going to fit in alternating currents or not. But optics for sure is something that will be placed, and I will get that in probably at the end of the semester. So that way you'll be prepared to move on from this first year of physics. All right, so we've covered the syllabus. Let's go back to our table of contents. We're looking at D2L now. We've covered the add and drop dates. And we'll have to clean up the rest of the things, the attendance and the stuff working with lab information. I'll either clean that up in the next video with labs, or we're going to do it in person. I want to put an emphasis on that. I didn't do that emphasis as much as I should have in the first semester. If you were with me in this first semester last fall, I didn't put as much emphasis on the statistics of the labs, and I'm going to do that a little bit more for this semester. And so we'll take it from there. So this is our welcome to second semester algebra-based physics, and I hope you have a great time with this course and you enjoy it as much as I do. Believe it or not, I really do love this. So a lot of people would think, oh, he's just crazy, but I love teaching it, and I love that you guys pick it up, and every single time I see breakthroughs with you guys, it's just it's very satisfying. So best of luck on this course, and I'll have another video posted shortly.